Okay, let's get started. First of all, I want to talk a little bit about the exams that are still out. I usually wait until I've collected all the exams, and there were some exams that were taken out of class and things. So today, tomorrow, I'll be grading exams. You'll have your exam back on Wednesday. Okay. So just so you are updated on how that is going. Any homework questions? So we have 2 assignments due tonight, 3.4 and 3.5. So I'll take questions over either of those. Yeah.
I have just kind of like a general question.
Yes.
What trig identities should be known?
Okay, so what trig identities should be known? And I mean, that's a good question. I would say that right now, I would expect you to know kind of what I would consider the basics, in that like tangent theta is sine theta over cosine of theta, right? That secant of theta is 1 over cosine of theta, cosecant of theta is 1 over sine theta, cotangent of theta is 1 over tan theta, which is also cosine of theta over sine of theta. There's like sine squared of theta plus cosine squared of theta is 1. And then there's the kind of 2 brothers of this guy, which is dividing everything here by sine squared theta or dividing everything here by cosine squared theta. If I divide everything here by sine squared theta, I get 1 plus cotangent squared theta is equal to 1 over sine squared theta, which is cosecant squared of theta. Or if I divide everything by cosine squared of theta, then I get tangent squared of theta plus 1 is equal to secant squared of theta. But all of these are just derivative statements of this statement, right? So all of those for sure. And then you get into like the half angle identities, but I don't necessarily expect everybody to have the half angle identities or the double angle identities or any of those things memorized right now. When we get into calculus 2, you'll need to memorize the half angle identities, but for now, I don't expect you to have them memorized. But definitely all of this stuff, I would kind of expect that people know. Is that helpful? Was there something in particular that you're like, am I supposed to just know this off the top of my head, or?
Not really.
Okay. Just curious. Yeah, so these are all the things that right now. Now, also the one other thing that I would expect you to know from trig is just like, what if you have like a right triangle, and this is the angle theta, and you have like, this is the opposite side, the adjacent side, and the hypotenuse, how to find like tangent and cosine and sine using these sides, right? Like that cosine of theta is the adjacent over the hypotenuse. That would be another thing that I would kind of expect that people know from trigonometry. Yeah. Yes, sir.
Can you go over 35 on 3.5?
3.5, 35? Yes. 3.5, 35. Okay. So we're finding the derivative of the function. This is 3.5. Okay. So we have y equals w squared sine w plus 2w cosine w minus 2 sine w. Okay. So we want to find just the derivative. Is that right? Yeah, okay. So we want to find the derivative of y with respect to w, so dy dw. And that's going to be equal to, well, this first one is the product of two things. So we need to use the product rule on this. So we've got this is my first function, this is my second function. So I've got the first function, w squared, times the derivative of sine of w. The derivative of sine of something is cosine of that thing, plus the second one, sine of w, left alone, times the derivative of the first one, which is 2w. Okay, so that was the derivative of the first thing. Okay, now the second thing is also a product, so I need to use the product rule. So I get the first one, I'll group them this way, 2w and cosine of w. So it's the first one, 2w, times the derivative of cosine of w, which is minus sine of w, plus the second one, cosine of w, times the derivative of the first one, which is just 2. Okay, so that's the derivative of that second guy. And then the third one, I have minus 2. The constant doesn't do anything, it just stays. And then I take the derivative of sine w, which is cosine w. And that's it. Now the question is, could I maybe do some simplification? It looks like I could. Right here I see I have plus 2 cosine w's minus 2 cosine w's. So I suppose those cancel out. Anything else? Here I have a sine w times 2w plus a negative sine w 2w. So I suppose those cancel out as well. And then I'm just left with this guy. So I guess that the answer is just dy dw is equal to w squared cosine w. And that's all.
Quick question on the product rule.
Yes.
So if you end up like getting the orders mixed up, is that a problem or no?
Well, okay. No.
So like if
No.
instead of,
So if, like on this thing, you could take the derivative of this one first times this one, or you could take the derivative of this one first times this one, as long as the second one you flip it, right? It doesn't matter which one you do first. In the quotient rule, it does matter. Okay, so in the product rule, as long as you're taking the derivative of one times the other, then the derivative of this one times the other, you can't really get it wrong. But in the quotient rule, you can get it wrong. So you got to make sure you're starting out with the thing that's on bottom left alone. Yeah. Yes, sir.
70 from 3.5.
3.5, number 70. Okay. So 3.5, number 70. Okay, so they have, let's take a limit here. Evaluate the limit or state that they do not exist. Okay, so we've got the limit as x goes to pi over 4 of cotangent x minus 1 divided by x minus pi over 4. All right. Okay, they say to identify each as the derivative of a function at a point. Okay, so the question is, what does this remind me of anything? So what if I were taking the derivative of cotangent at the point pi over 4? Then what would I actually get? So let's say that f of x were equal to cotangent of x. Then what would be f prime of pi over 4? Right? That's the question. And there's different ways to write derivatives. But one of the ways to write a derivative is it's like f of x minus f of c over x minus c. The other way, limit as x goes to c of that. This is the limit of the difference quotient in one of the forms of the difference quotient. Sometimes we use an h on the bottom. This is like one of the other forms of that difference quotient. Let's just see what happens if I plug things in here. This would be the limit as x goes to c of f of x is cotangent x. F of c, well, what is that? What is cotangent of pi over 4? Suppose that, yeah.
Okay, it might be kind of off, but were we assigned 70 from 3.4 to 3.5?
3.5.
No, it was 3.4.
This one is 3.4.
Oh, am I doing a problem that was not assigned?
Yeah.
Oh, it's okay. It's still so fun.
Yeah.
But okay, maybe this wasn't assigned. But it's still an interesting problem. I was kind of thinking, man, that was mean of me to assign one that used an alternate form of the difference quotient. But I was like, sometimes.
Yeah, I did 78, not 70, sorry.
78.
Yeah, I
Okay. I could stop here, but anyway, this is really interesting. This ends up being 1. And on the bottom, this is x minus pi over 4. So really what I'm asking when I ask this, it's what's the derivative of this function at pi over 4? But we know what the derivative of that function is. Does anybody remember what it is? Of cotangent of x. What's the derivative of cotangent?
negative cosecant squared x.
Negative cosecant squared x. So if I'm asking what's f prime of pi over 4, what's f prime of pi over 4, then that would just be negative cosecant squared of pi over 4. And so now I just have to figure out what this is. And remember, this is negative 1 over sine squared of pi over 4. So I just need to know what sine of pi over 4. What is it? Root 2 over 2. So this is just equal to negative 1 over root 2 over 2 quantity squared, or negative 1 over, I suppose this would be 2 over 4, or a half, or negative 2. And that's how you do that one. That's kind of tricky, honestly, because you have to kind of recognize this as a difference quotient, but evidently I didn't assign it. So that sort of makes sense on that. Okay, did you want me to do 78? Or was that, did you have a different?
Yeah, that's okay.
You're good? Okay. Yes?
Can you do 45 from 3.4?
3.4, 45. Is that right, 45?
Yeah.
Okay. Okay, number 45. We have g of x is equal to x plus 1 e to the x divided by x minus 2. Okay. Okay, first thing before we get started, this isn't something that I talked about in class, but I probably talked about it in the lecture. What's the derivative of e to the x? E to the x, okay. Just making sure we're all on the same page with that. Okay, so what I see when I look at this problem and I want to take a derivative is the first thing I see is it's a quotient. It's a function divided by a function, right? So I say, okay, I have something divided by something, then I want to use the quotient rule. So the quotient rule says, take whatever's on bottom and write it down. So x minus 2. Then I want to multiply that by the derivative of what's on the top. But what's on the top is a product, right? So I have to use the product rule to take the derivative of the top. So when I multiply by what's on top, I'm multiplying by a product rule. So it's the first one, x plus 1, times the derivative of e to the x, which everybody just said was e to the x, plus the second one, e to the x, times the derivative of the first one. But the derivative of x plus 1 is what? Just 1. So that's it. Okay, so far I've got the bottom times the derivative of the top, and then I go minus, and now it's the top is written down, which is x plus 1 e to the x, times the derivative of the bottom. But what's the derivative of x minus 2? Just 1. So I can just leave that as is. So I've got the bottom times the derivative of the top minus the top times, I suppose, 1 is the derivative of the bottom, divided by the bottom, x minus 2, quantity squared. And honestly, that's where I would probably leave it. You could multiply this out and try to simplify the top a little bit, but it's not going to get that much better in this situation. So what I would always suggest is just leave it like this. Now, when would I not leave it like this and start to simplify? If I needed to take a second derivative. So if I ever need to take a second derivative, I would say, this is a mess on top, and I don't want to take a derivative of that. So I should probably simplify it a little bit on top to try to make it nice so I can take that second derivative. But if I'm just taking a first derivative, this is the first derivative. It's just not like super clean. So on an exam or something, just write this. This is good enough. Yeah.
Is that okay for homework?
It is. Yeah, it's fine for homework. If they're just asking, take the derivative, this is the derivative, and that is fine for your homework. Yeah.
Does it matter for you the product of quotient rule first?
It does, yes. So, because if you think of this thing as, is this thing a function times a function, or primarily is it a function divided by a function? When you just look at it, I say it's a function divided by a function. So it's first a quotient rule, then it's a product rule, if that makes sense.
Yeah.
Because it's like the product is embedded inside the quotient. Could it ever be the other way around? Yes, it could. So like, let me give you an example of where it would be a product first and then a quotient second. Maybe I have something like sine of x over x minus 2 times x cubed minus 2x plus 3. Okay, if I were given this as my function f of x, then what I would probably say is, look, first and foremost, this is a product, not a quotient, right? The quotient is inside that product. So this is a product rule in which, while I'm doing the product rule, I'm going to have to use the quotient rule. This is a quotient rule in which I'll have to do the product rule. Do you see the difference?
Yeah.
So it's kind of like, look, this is something times something.
Could you combine those two on the bottom?
You could. So maybe I maybe could have written an even more complicated thing where it would have been harder. But like you said, could I just multiply these two and then just have one quotient? Yes. And here, I suppose that I could write this as, this is x plus 1 times e to the x times 1 over x minus 2. So if you wanted to write it this way, now this is a product where you'll have to do a quotient rule on 1 over x minus 2. So that would work also. But you have to make sure this is what you're doing the product rule to, not this, if that makes sense.
Yeah.
So it's all kind of the same-ish, but you have to be careful. So the big thing is just decide on what's my strategy here. And when I look at this, it's like my strategy is to group this is one thing, this is one thing, and then use the quotient rule. Does that make sense?
Yeah.
Yeah.
Thank you.
Other questions? Let's see, I have some on mine, I think. Somebody said 45 and 49. Let's see on which. 45 and 49 on which section? Is there only one section where those are both assigned? 3.4 maybe?
Yeah.
Okay, I'll do 49. I think I already did. Yeah, I just did 45. So 49. So 3.4, 49 is G of W is equal to square root of W plus W divided by square root of W minus W. Okay, so on this guy, again, similar to last time, I look at it and I see it's something divided by something. So that kind of tells me we should probably try the quotient rule. Okay, so we get G prime of W is equal to, so I just follow my rule, it's the bottom, square root W minus W times the derivative of whatever's on top. So the question is, what's the derivative of what's on top? What's the derivative of the square root of W? Yeah.
Wouldn't the square root of W be the same thing as like squaring W by 1/2?
Yeah, it's the same as W to the 1/2 power, right?
So can't we just use the 1/2 in front of W and then minus like 1 from 1/2 to make it like 1/2 W negative 1/2?
Yes. So it would be, so the derivative of W to the 1/2 is 1/2 W to the negative 1/2. And maybe we could write that a little different. We could put the W on the bottom, but for now we'll just leave it. And then the derivative of W, of course, is just 1. So this is the bottom times the derivative of the top minus the top square root of W plus W times the derivative of what's on the bottom, which is similar. It's 1/2 W to the negative 1/2 minus 1, right? Divided by the bottom, square root of w minus w, quantity squared. Now, officially, this is the derivative. Could I simplify this and make it a little more pretty? I think almost certainly, if you wanted to. So like this one could be rewritten. I'll just do it really quick. This is the square root of w minus w times, this is 1 over 2 square root w. Right, because the w to the negative 1/2 goes on the bottom as w to the 1/2, which is just square root of w, plus 1, minus square root w plus w times 1 over 2 root w minus 1, all over square root w minus w squared. Okay, something that if you start multiplying these things together, I think what you'll see is that kind of some nice things happen. There might even be some cancellation at the end, and it might get kind of nice. So if you wanted to simplify this more, you certainly could. And I'll let you try it if you would like. But like I said, if you were doing this on an exam, I would just want you to leave it right here. Okay. If you were needing to take a second derivative, certainly keep going with this and make it as clean as possible before you start trying to take another derivative. Because if you wanted to take a derivative of like this, that's really bad. Because there's like a quotient rule, a product rule. It's bad. So clean it and then take its derivative again. Other questions? Yes, sir.
More of a concept question, I guess.
Sure.
So sine of h over h is 1. But
Yes.
in 19 for 3.5, it says sine of x minus 2. So can you make it sine x minus 2 over x minus 2, and that's still 1? Or is it only 1?
Okay, which one is this?
19.
On 3.5, 19. Okay, yeah, so, oh yeah. So you've got sine as x goes to 2 of sine of x minus 2. Okay, yeah. So this is 3.5 or 19. It was the limit as x goes to 2 of sine of x minus 2 over, I believe it was x squared minus 4.
Yes.
Okay, so yeah, you have the exact right idea. You're kind of saying, okay, well, this is going to 2, not to 0, right? And this, but that makes this go to 0. So what I would suggest is like, let's make a change of variables. So, and what I mean by that is, why don't I just say that, let's call it w, and I'll just say that w is x minus 2. Okay, so if w is x minus 2, then how could I rewrite this? So if x is going to 2, where is w going?
0.
Yeah, 0. So this could be written as the limit as w goes to 0. Because if x is going to 2, w is going to 0 of sine of w over, so here we have x minus 2. This is right here, right, is x minus 2 times x plus 2. Well, x minus 2 is w. X plus 2 is what? So if I added 4 to both sides of this equation, then I'd get that w plus 4 is x plus 2, correct? So x plus 2 is the same as w plus 4. And so this is exactly the same thing as this. Does that make sense? So I just made a change of variables, and now I've got the limit as w goes to 0 of sine of w over w, but of course I know that's 1. And then the question is, what about when w goes to 0 here? That's going to be 4, right? So this is equal to 1 times 1 over 4, or just a fourth. Does that make sense?
Yeah.
Yeah.
So it's just whenever the limit is going to, or make the limit go to 0.
Yeah, and it has, the thing inside the sign has to be going to 0. That's right. And it needs that same thing to be on the bottom. So, yeah. Other questions?
Could you use 43 on 3.5?
Yeah, 43. So 3.5, 43. .5, 43. So y equals sine x plus cosecant x. Is that the one?
Is it sin x or secant?
Oh, I'm sorry, secant x plus cosecant x. Yeah. Y equals secant x plus cosecant x. Correct? Yeah. And just find the derivative. Okay. So y prime is equal to, so what is the derivative of secant of x?
Cosine?
No. So the derivative of secant of x is secant x tangent x. And if you ever forget, like if you were on an exam or something and you forgot, the other way of thinking about it is that secant of x is 1 over cosine of x, correct? And you could then just use the quotient rule on this to find the derivative. But the quotient rule would say that the derivative of 1 over cosine of x is cosine x times 0, or the bottom times the derivative of the top, which is 0, minus the top, which is 1, times the derivative of the bottom, which is minus sine x, over the bottom, cosine x squared. Correct? Which is what? So this is gone. This is sine of x on top. And then I have a cosecant squared of x on the bottom. So, but I could write that as a cosecant x here and a cosecant, I'm sorry, I'm saying the wrong word. A cosine of x on bottom here and a cosine of x on the bottom of a 1. But sine over cosine is tan x. And 1 over cosine is secant x, right? But it's what we need to just remember is that the derivative of secant of x is secant x tangent x. Okay, we just need to remember. And then what's the derivative of cosecant of x? It's very similar. Anybody remember?
Negative cotangent x cosecant x.
Yeah, negative cotangent x cosecant x. Yeah, and that's the answer. So if you just kind of memorize those two derivatives, this one comes out pretty clean. But if you ever forget, you can just turn it into sines and cosines and then use the appropriate rule to figure it out yourself. Okay, so if you forget, but you should know the derivatives of those 6 trig functions.
What is the last one?
Yeah, what's the derivative of cosecant of x?
Cotangent.
It's negative cotan x cosecant x.
Okay, but what is the derivative of cotangent?
What's the derivative of cotangent? It's negative cosecant squared of x. One of the things that's kind of nice is that if it starts with co, it's always negative. So all of like sine, tangent, and secant, they all have positive derivatives. Cotan, cosecant, what's the one? Cosine, right? Those three all start with co. They all have negative derivatives. So that's kind of a nice little thing to remember is that cos always have a negative. All the others do not. Yes,
Can you do 59 from 3.4?
3.4, 59. Yeah. Okay.
3.4, 3.5.
3.4. Is the square root one?
So 3.4, number 59 is f of x is equal to the square root of e to the 2x plus 8x squared e to the x plus 16x to the 4th. Okay, and they even give a hint, factor the function under the square root first. All right. So if we do what we're told and we factor this thing, I'm just taking a guess here based on what I see. The square root of that thing is just e to the x. The square root of 16x to the 4th is 4x squared. So wouldn't it be wonderful if that were just squared? And let's see if that's true. E to the x squared is e to the 2x. 2 times the first one times the second one is 8x squared e to the x, which is this. And this one squared is this one. So this is perfect. And now, of course, things are kind of wonderful. The square root of this square is just e to the x plus 4x squared. And now we just take the derivative of e to the x plus 4x squared.
And if it was 3.5, would that get mixed up?
There's a 59 on both.
Yeah, this one, well, this is, I did the one from 3.4, but I don't know. It's, any other questions?
Okay, so this might be like e to the x, so then the 3 to the x also just be 3 to the x.
Good question. The answer is no. And we are going to do that. We haven't done it yet. So we'll do a whole section on exponentials and logarithms. But basically, I can tell you the answer. But let's see, if you have y equals 3 to the x, that was your question, right? Well, it ends up that the derivative dy dx is very similar, actually. It is still 3 to the x, but you have to multiply it by an additional natural log of the base, which in this case is 3. Now, you actually do that with e to the x too. You multiply by ln of e, but ln of e is 1. So it ends up not being there. So e is just the special number where it comes out to be exactly itself. All of these other ones, like any other base to the x, you multiply by the natural log of whatever the base is. And I'll kind of prove that more formally when we get there, like, well, why? Yeah. but that's the answer. Other questions? See if anybody else asked anything. Not yet. Somebody advertised online that they have solved a bunch of math problems online, but other than that. Okay, then we will end there today. The next section is assigned, and I will see everybody on Wednesday. Have a good day. By the way, if you're coming to class on Wednesday, you'll be able to pick up your exam on Wednesday. If you're not coming to class on Wednesday, you could swing by my office on Wednesday and pick up your exam if you would like to. Okay? If not, I'll have it for you on Friday. Have a good day.